What we're going to be talking about in this session is a little deeper dive into the phrase navigation that we use to name the session is not really as accurate as maybe the phrase orientation or maybe tracking. Because we're essentially pointing a virtual camera at a place in space whenever we're in Starry Night, things can move in different and unique ways with respect to us, and we can move in different and unique ways with respect to objects. And the way Starry Night handles this is it's not like a 3D program like a 3D Studio Max or a Blender where we're positioning a camera, a virtual camera, and then telling it to slew or track or pan or anything. The way this works in Starry Night is that the physical motions of the universe determine how everything moves, and we just choose how we decide to be in space in order to have that movement work. So generally, when time is flowing and things are moving around, that's what's creating animation. We don't say, I would like to go up and over Mars and down past it and then beyond by moving a camera around. We just let Mars do its natural motion through space, and we park ourselves in different ways in order to see those things. So there are two kinds of these effects. There's a style that's called tracking, and there's a style that's called orientation, and they have different functions. I'm going to start with tracking. Tracking is a little hidden. It's a little buried in the Starry Night controls. This area of your screen up here that tells you where you are with respect to a body, it might tell you that you're in Stonehenge, or it might tell you that in this case, we're almost 10,000 kilometers away from Mars. Living under there were those controls that allowed us to set our location. And much lower on that list, if we right click in this area, if you see the description of where we are in space, like 10,000, 9,000 kilometers from Mars, and we right click on that, lower on the list, we're going to see an area called tracking. And we're going to start with just two of these tracking controls, okay? The two options that you're interested in are rotate with Mars and hover as Mars rotates. And they basically do what it sounds like they do. I'm going to set my speed to like 300 times real time. In fact, I'm going to speed that up a bit so you can see things fairly clearly. Something you're going to notice as we rotate through space here is that we are basically looking at the same point at Mars as space spins around. Or perhaps a better way of saying that is we're looking at the same point on Mars's surface as the background stars move relative to it. I kind of like to think of this as standing on a really, really tall ladder, a 9,000 kilometer high ladder. And as we run space time forward, it appears that we're stationary on the surface, right? We're just hovering over the same spot and the background stars are moving. That tracking would be the one that we call rotate with, right? We are connected still to Mars's surface, and as it rotates, we rotate with it. So we see the same point at Mars all the time, and we see the background stars moving, okay? The opposite of that would be if we hover over Mars as it rotates. So this time I'm going to go back into this area of my screen that tells me where I am with respect to Mars. And again, that's kind of a good way to remember it. If we see where we are with respect to Mars, we can change how we move with respect to it too. So we're 9,000 kilometers up. If I right click in that area, I can also tell Starry Night to hover as Mars rotates. And that's going to do exactly what it sounds like. Now the background stars will be static and Mars will rotate with respect to us. And that's a very different effect, right? Now what we're seeing is a static background star field, and we're seeing this object turn in a lovely way. But you'll notice the sun is not moving, and so we're not seeing the phasing, the Terminator move us across into the dark side. We just see the object hovering there in space. And here's the thing to remember, you might even note this. Hover also always means hover in place. And this is going to be important later. No matter where Mars is sitting on the screen, if we're in this hover mode, whether it's up here or way down here, Mars is going to be parked there static in the sky. It's not going to move around, okay? So you can also think of hover as hover in place. Wherever we have Mars on the dome, it's going to, if we advance time, it's going to sit there and rotate around. So let me review tracking one more time. We're currently in the hover tracking, right? And if I want that opposite effect, if I want the background stars to appear to move and the object that we're hanging over, the planet in this case, to appear to be the thing that moves, I set to, let me close out of Outlook so you guys don't have to see my pop-ups there. So now that we're in rotate with, again, it's as if we're connected to the surface. We're rotating with Mars. It appears to be static and the background stars appear to move, okay? So those are the two most common tracking modes that we use. There's a third one that's even a little bit more creative. And in order to do this one, I'm going to set my time to be very slow. I'm going to set it down to maybe 20 times 20x real time, okay? This is the very bottom tracking on our list. And I'm going to right click in this area again that tells us where we are with respect to Mars. And I'm going to do a thing called switch to stationary location. What's cool about this one is it actually parks us in space with respect to Mars's orbit. So what will happen is I advance time is I'm going to stay in the same place with respect to the sun. And if I speed up time a little bit, you'll see what happens. Mars continues off in its orbit as I stay parked in space. Why would I want to do that? It's a really pretty way to fly, just a simple way without using more sophisticated navigation, a very simple way to fly past a planet. If you don't want to build like an animation in our automation software, you just want to see a planet kind of slowly flying past us in a pretty way or disappearing off into space, that switch to stationary location is a really great way to do it. The problem is because Mars is orbiting the sun now, we're parked with respect to Mars's orbit. If you turn the speed up too fast, it's just going to go zipping by us really quickly. Watch how quickly it goes by. Zoom. That was it going by really fast. You probably barely caught it. So you always want to do this at a fairly low speed, okay? Somewhere down in the 30, 40, 50 range, all right? Now, if we get lost, if we lose Mars, all we have to do is go to Mars again. If I right click on Mars and I say go there, I can just hit the space bar. That's going to take me right back to Mars, okay? So I'd like to review those guys one more time. And I'm going to ask a question. Somebody shout out the answer. If I want to see Mars just rotating in place, the background stars are not moving, Mars is just spinning around in front of us, which of these trackings am I going to use? Jeannie, I'll put you on the spot.
Is that the hover?
That is hover. You're right. How do I do it? Where does my cursor go?
Hamburger next to location.
That'll work. Yeah. Hamburger next to location, or I can also, I tend to right click. I don't know why. That's how I do it. Hamburger here would do exactly the same thing. I'm going to go down and I'm going to find tracking and I'm going to hover as Mars rotates. And if I turn my speed up far enough, you're going to see Mars spinning in place. Okay. And if I want the opposite of that, if I want Mars to appear to be stationary and I want the background stars to appear to move, that's when I would use rotate with Mars. Okay. That's a great demonstration if you want to show why we move from daylight into night, right? As the planet rotates, we see the Terminator moving across the surface of the planet. We see ourselves moving from day into night. And then that kind of creative one, that one that's sort of fun if you want to do a nice animation where the planet flies by you through space, is we would go follow Mars in orbit. Do I want to do this right now? Do I want to hit my play button? Probably not, because if I do, it's going to go off in its orbit really quickly. So I'm going to set this to a slower value, like 30x, or maybe I can drag it up to 60x. And if I play time forward or backwards, that's a bit slow to see it. You'll actually see that body moving past us. Did I not get there? Follow, oh, sorry, wrong one. Switch to stationary location. There we go. And unless your time is set quite slow, it's going to fly by us pretty fast. So you want your time to be set 100 or lower a little bit. The further you are out in space, the slower the objects seem to move. There we go. Okay. Any questions specifically about those 3 tracking modes?
Yes. Can you change where you hover over the object? Like, could you hover over the pole, one of the
You bet.
poles?
Yes, you just have to be careful how you do that. And this is a little gotcha. If I use my location scroller right now, if I enable the location scroller and I drag the planet around, or if I change my elevation, look where I really am in space. I'm actually now over an astronomical unit, 1 AU away from the sun. We did that so that I can park myself really with respect to the sun's position and all the planets move with respect to me. So if I do any kind of change, Mars is going to disappear because I'm rotating Mars around the sun, right? I'm no longer rotating Mars. We're not rotating us around Mars. We're rotating it around the sun. So here's how you want to do that. That was Rick who asked that question. Here's how you want to do that. Before you switch to stationary location, I'm going to take us back to Mars. I'm going to go there, hit my space bar and put us back at Mars. You want to do all that positioning before you switch to stationary location. So say we want to be looking down at the pole like this, and we want to be a little bit closer to the planet. All right. Now that I've positioned it that way, now I can safely, after I've got it where I want it, now I can safely go switch to stationary location, and it'll do exactly what you expect it to do. Just remember that if you're in stationary location and you try to grab the planet and move it or change your elevation, it's going to go flying off at a high speed because you're really spinning the sun now, right? You're spinning our position around the whole orbit of the sun. Did that answer your question, Rick? All right, good.
Yes, I was thinking more from the hover option.
Oh, absolutely. Sure. Sorry about that. I thought you were talking about that. Yeah, you can position yourself wherever you want. Now that we're over the pole, if I say hover as Mars rotates and I play time forward quickly, you'll see again exactly what you would expect to see. You're over the pole. Do you recall the lesson where Dave Bradstreet did where he was showing the moon orbiting around us and he had positioned himself under the Earth's south pole? He was using hover over the Earth there. Okay. Any other questions about tracking? All right, I'm going to talk about orientation now, and this gets maybe one layer more complicated because what orientation does is rather than us moving around with respect to a body, kind of how we fly around it or how it moves relative to us, we take the entire coordinate system that we're in the universe and we mess with the coordinate system. Clear as mud, right? I'll explain what I'm talking about. First and foremost, a thing that you'll notice about a planet or an object, a 3D model, an asteroid, whatever we happen to be hovering over in space, you'll notice that I can spin around it, right? I can turn it and twist it. I can grab that body and I can move it up and down. And I can grab the entire sky and rotate it around our visual z-axis, right? We can sort of spin it around like a doorknob. What I can't do in this mode is I can't drag Mars off of the meridian. It's locked to the middle of our dome, or more accurately, right in front of the audience, right? Directly in front of us. And one thing I can't do is take it off that center axis. Normally that's a good thing, right? Most of the people in most planetariums are looking straight ahead. You want to keep the interesting object straight ahead. But there are times when you want the ability to move the planet off center. And that's where we use orientation, okay? Orientation is also located in a place that might be a little bit hard to remember. If you find your way up to your options menu, not the options window, but the options menu at the top left of your screen, and you select options, down near the bottom of the list, about actually around halfway down the list, you'll see something called orientation, about 3/4 of the way down. There are only two that we're going to worry about for this course. We're in local or standard orientation, which means that the object is always locked to the front of the dome. It's locked to the meridian of our local coordinate system. The other one we're going to use is ecliptic. And the interesting thing about ecliptic now is that it will allow you to move a planet anywhere you want around the dome. Okay, you can put it to the left, you can put it to the top. And when you use your location scroller, if you hold your shift key down, now rather than spinning the planet, it will position it anywhere around the coordinate system, around the ecliptic. And here's how I think of this. There's kind of a fun way to think of this. I'm going to turn on the ecliptic grid. And just to make it a little clearer, I think I'll turn those labels off so all you see is the grid, okay? Now, has anybody ever seen that circus act where they have a big metal sphere and they drive a motorcycle or multiple motorcycles in and they ride around the sphere? That's kind of what Mars is doing in the ecliptic system. If I use my location scroller, if I hold my shift key down and I scroll around, it kind of looks like Mars is anchored to the edge of that sphere. And what we're doing is dragging it around the ecliptic sphere. And if you've done this enough, you actually kind of get to know where the zenith of the sphere is. This little area where I can do a small rotation, that's the zenith of the ecliptic sphere. And the further away it gets, the bigger a movement it does, right? But the thing to remember, if that's sort of complicated, is just that when you're in ecliptic orientation, you can put the body anywhere you want on the dome. So let me review where we got to that one more time. If I go up to the options menu and I say orientation local, that forces our body to be right on the front of the dome, regardless of whether I drag it up and down or I spin the sky or I use my location scroller to move the planet, it's always at the front of the dome. In ecliptic orientation, if I go up to options, orientation, ecliptic, that's the mode that allows me to put it anywhere on my screen. Any question about those two orientations? So let's see. Taylor, I'm going to put you on the spot for a second. You want to turn your microphone on for just a minute.
All right.
All right. So if I wanted, let's go back to, I'm just going to set this back to orientation local for a second. If I wanted to watch the Terminator sweep across the surface of Mars, see it move from the dark side to the light side, and I want my background stars moving, how would I even begin to do that? Where would I start?
You would go to options.
Well, is that orientation or is that tracking?
Oh, you would click the hamburger beside your location.
Uh-huh. And which one would I select? We want it to look like the planet doesn't move underneath us. It's the stars moving and we're stationary with respect to the planet. So which of those would I use?
Follow Earth in orbit or follow Mars in orbit.
No. We didn't even, that one's kind of a weird, subtle one. We would rotate with Mars, right? Because that'll keep us at the same point on Mars's surface. So
Okay.
now if I run time forward, so again,
and it'll rotate to its
it'll
start.
rotate and you'll see the background stars moving, not the planet. So now if I wanted the other approach, if I wanted it to appear to be rotating and the background stars to be static, what would I do?
Hover.
And how do I get to that?
The hamburger beside your location, and then tracking. Hover.
And then hover. Okay, and now what I'm going to see is Mars just appearing to spin in place. and the background stars appear to be static. Okay, Rick, why don't you unmute, and I'm going to put you on the spot. Now, you'll notice as I move Mars around, no matter what I do, it's always locked to the center of the dome. Which orientation am I in?
Oh, that's one where it's on the, not sure of the term, right in the middle.
I'll let you off the hook. We call that the local or the standard system. That's what we
Right.
call our local orientation. But if I wanted to be able to reposition Mars to any place on the dome, first of all, how would I even begin to do that? Where on my screen would I access that?
Okay, you're going to have to go all the way to the top, to options, not display options, but options up above, and go to orientation. And then we'll go to the ecliptic.
Right. And we're going to ignore those other ones. They get a little funky, but ecliptic is the useful one that allows us to move the planet anywhere we want. Okay.
Now, did you use funky because you picked me?
No.
Oh, okay.
Sorry. That would have been either clever or really goofy of me, but no, I that's a word I use often, but thanks for
Yeah,
pointing.
no, that's all right.
Okay. So ecliptic is the mode, the orientation that allows us to shift our planet to anywhere we want on the dome. Okay. So I'm going to get a little more complicated here. And I know we're building a kind of a large truth table in your head. You've got to keep track of 2 trackings. You've got to keep track of 2 orientations. I'm going to put them together now. Okay. And these are all in the course notes, by the way, so you don't have to memorize this, but I want you to see what the capability is. So if I put Mars, I'm in ecliptic orientation, right? We know that because I can move Mars to anywhere on the dome. Do you remember that I said hover can also be thought of as hover in place? When you hear the term hover, you can actually sort of substitute the term hover in place for that. And here's what I mean. If my tracking is set to hover and I run time forward, no matter where Mars is on the dome, it's going to hover in place, okay? Just try to remember that term hover in place, because it means when we're in the hover orientation, or hover tracking rather, no matter what orientation we're in, if I'm hovering, I'm going to hover in place. So this can be really pretty, right? We could have Mars way off to the side and kind of to the rear of the dome, and it's parked there hovering. We're hovering as it spins around in a pretty way, right? So no matter which orientation you're in, hover always means it stays in place. It's a really useful effect. So if you're getting bored in your shows and you're getting tired of, you know, the Earth is always spinning in front of you, Pluto's always spinning in front of you, consider using the ecliptic orientation, and you can get some really, really interesting views of that planet, like off to the side of the dome, just hovering in space there, right? You could be showing constellations as they look from near Mars. You could be showing other bodies, zooming into other bodies with Mars on one side of the dome or the other, all right? That's what happens when you hover. What happens when we switch to, slow it down a little bit, when we switch to rotate with? It's the motorcycle going around the sphere. So when you're in the ecliptic orientation, you have 2 choices you can make. You can be in ecliptic orientation and the object can just hover in one point, right? Or you can be in the ecliptic orientation and it's going to do the motorcycle trick. It's going to ride around the sphere. You get that by doing rotate with, okay? I'm not really sure why that's happening from a physics perspective. Don't ask me. I don't know why ecliptic orientation and rotate with does this, but if you wanted this effect, if you wanted your planet to kind of fly around the ecliptic system like this, let's say you just wanted to skirt the edge of the dome like that. Again, if you don't remember all those, I was going to say funky again. If you don't remember all those interesting combinations, they're all in the course notes. But I think a cheat for remembering this, a good way to kind of keep this in your mind is if I'm in the ecliptic orientation, if I can position it anywhere in the dome and I want it to sit there statically rotating, if I remember the phrase hover in place, if I set it way over here, that's fighting me. If I set it way over there and play time forward, it's hovering in place. Any questions about that one? I know we've got a lot of different options here. All right. Let's go somewhere else in the universe just because I'm getting bored with looking at Mars. Let's go to Earth. I'd like to show you one other way to move with respect to objects that gives you a little freedom to do things that you can't do specifically with those effects that I've just shown you. And in order to do this, I'm going to look at starball controls. Typically, we think of starball controls as being used exactly like they were used in an old optomechanical planetarium. Annual motion would move all the planets through the sky without moving the background star field. So we could see the planets moving through the seasons and the background stars would just stay parked. Daily motion would just move us around the Earth. It would basically run us around the Earth in latitude or in longitude rather. Latitude would move our sky either toward the North Pole or toward the South Pole. These all do exactly what they sound like they do. Longitude, again, runs us around the Earth in longitude. Heading would spin the entire cardinal point system around us, like turning our head left and right. So I want to show you an interesting use of the starball controls when you're out in space. I'm going to use one of the starball controls called daily motion. And this was designed from looking at the Earth from the ground to just move the sky in longitude. We basically run around the Earth without time flowing, right? The satellites don't do their stuff. The moon doesn't orbit around us. It's just running around the Earth in longitude. And we get that same thing. If I go to my starball controls and I just increase daily motion, this is different, completely different than the other two. Not only does wait one sec. I think. Sorry, folks. I think I'm still in ecliptic orientation. Okay. Sorry about that. I need to be in local. My bad. Notice what's happening when we're in this starball mode. Not only are we rotating around the Earth, but the background star field is also moving with us. Let me get us kind of in a more intuitive looking place on the Earth here. And sorry about that. I messed us up by being in ecliptic orientation. Let me just get the Earth positioned like that to a point that we kind of recognize. Watch again what happens when I do daily motion. The Earth is spinning, but so are the background stars. You get both in this case, okay? Right, with our tracking, we either had the Earth moving or the background stars moving, but not both. This is the equivalent of us like flying around the Earth in a spaceship, or to be more accurate, we're moving around the Earth in longitude. It's like we're actually physically flying around the Earth. So this is a really pretty effect. If you're just looking for something a little different, if you want to see us move from nighttime into daylight, but you want to see the stars go with it, this is really lovely, right? This is what the astronauts would see. As we cruise around the Earth, the sun rises, it moves over our head to our zenith, it sets on the other side. So this is the kind of look you can get with daily motion. Another one that can be useful, let's just say for the sake of argument, like all of these movements rotate us around the Earth, you know, as if it's rotating on its poles. But what if we wanted the Earth to move in the other axis? What if we wanted the Earth to rotate this way? We could use our latitude. So we're actually flying north toward the Earth's North Pole here, or we can fly south toward the Earth's South Pole. I think Brad gave an example before with starball motions. If you wanted to park yourself over the rings of Saturn and watch yourself move from above the rings to below the rings, or the opposite of that, we could do that. So why don't we try that? I'm going to take us to Saturn very quickly, or right-click Saturn and go there. If I use my latitude control now to fly toward the south, just a quick and dirty trick. You could do all these with the animation trips that we're going to learn later in the next session. But if you're just looking for a very subtle motion in your show, say you're talking about Saturn in your show and you just want a little bit of subtle motion, if you just set a little bit of latitude motion, you can barely see it because my screen's pretty small, but we're just gradually getting flatter and flatter with respect to Saturn's rings. Okay. Any questions about starball motions? All right. Just the two things to remember there is if I use daily motion, the nice thing about it is both things move. The planet moves, or the object we're hovering over moves, and the background star field moves with it. And latitude is the one that will allow you to spin the planet toward or away from the North or the South Pole. All right. So we've got about 15 minutes left in the session. I'm going to change gears on you a little bit and talk about how our preview screen works. When we get into animation, when we get into the next session and we talk about navigating through space, turning planets and moving planets in a more creative way as an ATM-4 animation, or getting near to them or flying over them or whatever, we're going to have to understand how to do some of those motions with our preview screen. But before I move on to that, is there anything else regarding the orientations and the tracking that we did before? Does anybody want a review of any of those or see any of those options again? Don't be shy. I mean, it's, you know, these are tricky and these are easily forgotten. So I'm happy to review any of that. Okay. And again, they're all in the course notes, so feel free to consult your course notes if you want to learn more about these guys. All right. Let's go back to Earth again. A little bit of this is going to be review because Brad and Steve probably ran you through how to use your controls to manipulate your view here. But I want to just review a couple of things so you understand what we're doing when we're in animation mode. So there are a handful of ways that we can move ourselves with respect to a planet. There are really three things that you can do to change where you are with respect to a body or the surface of that body. The most obvious one is elevation. We can sort of use this little arrow up and down as like a rocket up and down. And one thing I want to remind everybody of too is that the pre-flight can be set the way I have it set right now to be very responsive in our responsiveness preferences. I like my pre-flight to be nice and zippy, to be really quick, but that's not necessarily very aesthetically pretty. So what we do over on the render box side is we'll set our preferences to have the render box react more slowly. I covered this in the last session. We go to our render box responsiveness preferences. And this is why we would have these set fairly slowly, is if I fly away from the Earth very fast in pre-flight, I may want that to be happening much slower on the render box. I want that to be smooth and very pretty, right? So even though I flew away from Earth very quickly on pre-flight, on RenderBox, it's happening very slowly and very smoothly. It's a very pretty, very aesthetically nice flight, okay? If I go back to Starry Night, again, because I have my RenderBox responsiveness set pretty slow, again, I can do this really zippy, quick fly up to Earth, but over on my RenderBox, I'm coming into Earth nice and slowly. So Elevate is your rocket ship that takes you away from a body and toward a body again, all right? Another move is what we call a scroll. And in the ATM-4 world, we actually call this a change in location, okay? This is changing our location with respect to Earth, right? We're over America, we're over Africa, we're over America, we're over. This is a location change as far as ATM-4 is concerned, all right? So we're doing location, and again, we can do a little scroll. And the great thing about this is if I do a really aggressive scroll here, and I look at my render box, if I do it quickly enough, I'm missing I have two screens going. I did it too slowly. Let me do that again. I'm gonna do that, and I'm gonna see how that can happen quite a bit more slowly. So I'm changing location fast here, but the location changes very slowly over here. And then the third kind of movement is what we call panning or centering. A pan is when we grab the whole object and we pan it up and down, okay? Let me just move my screen so you can see this much more clearly. So if I pan up, you can see that that can happen quite a bit more slowly. And all of these can be stacked on top of each other. I can do a scroll and a pan, and you'll see them happening smoothly together as a combination there. So I can pan the Earth up and I can spin it. And over here, they combine with one another to form that motion, okay? So we have elevation changes, we have pans, and we have changes in location. All right, those are the three things we can do. I know this was covered in your basic course, but there's one thing that I would like to show you that is really, really useful. And in order to do this, I'm going to set up kind of an orrery view, all right? I'm going to take us to the sun. So I'm going to right click on the sun and I'm going to say, go there. And then in order to get this orrery view, what I'm going to do is turn on the orbits of a bunch of planets. So Mars and Jupiter, Saturn and Uranus and Neptune, okay? And now using my elevation, I'm going to fly us pretty far away from the sun so that I can see something that looks like the orbits of the planets around the sun. Now, you guys may recall, if we're close enough to an object, if we're right up close to the Earth, for example, and I hover my cursor over the Earth, it creates that little cursor, what we call a location scroller. It's the little arrow pointing up, down, left, and right. And that was the thing that allowed us to spin the Earth around its center point of rotation, right? But when I'm out here, if I hover my cursor over the sun, it doesn't spawn that little scroller. The sun's just a little dot and I'm too far away. So if I hold my shift key down, while I'm holding my shift key down, my cursor always becomes the scroller. So now I can rotate around the center point of the sun and change our angle with respect to the sun. I can flatten this out, okay? So when we want that kind of classic orrery view like this, that top down, looking down from Draco viewpoint of the solar system, or what's known as this is called a curtate view of the solar system, if you've never heard that term. Our location scroller is the thing that allows us to change our angle and rotate anywhere around the sun we want to be, but you need to hold your shift key down in order to get it, okay? All right, so I'm going to test your understanding of these orientations a little bit with this orrery. And I'm going to test a little bit of your knowledge in Starry Night since we've got about 5 minutes left. Brad may have run you through this exercise, but I'm going to do it again. First of all, this is one of the times where I don't think I want my sun down near the edge of the dome because I can't see the whole orbit, right? I'm shifted so far to the bottom that I can't see the orbits. What if I wanted my sun in the middle of my dome? I wanted it higher up on the dome. Rick, I'll put you on the spot again. How would I change things so that my sun actually was sitting up at the zenith of my dome? How could I do that? Remember how we talked about where the audience is looking? That was actually a preference. That's a thing called the focus of interest, right? So if I go into my file menu and I go to my render box preferences and I set my focus of interest to be at the zenith and I close out of it, now Starry Night is going to allow me to have the sun up at the zenith. That was that thing I talked about where Bradstreet in his scripts will sometimes change that with that focus of interest cue and put an object up at the zenith like that. All right. So another way to test your knowledge, I've got kind of this orrery thing happening, right? But I can't see the planets. We're so far away from them that they're way too small to see. What if I wanted to sort of, in an artificial way, make each of the planets bigger in place here so that I could clearly see Earth really big and clearly see Mars really big and clearly see Jupiter really big? Is there a control that I have somewhere here that would allow me to make those planets bigger?
I don't see it on yours, but I think there's a slider in there somewhere that you can change the magnification of the planets.
Yeah, this is a little bug in Starry Night. I actually have to go to another. If this happens to you, if you lose some controls over here, it's a little tiny bug in the user interface. Do this, just go to the hamburger and change it to anything else, like constellations, and then go back to planets. Sorry about that. It's a bug we've got to kill. I've been meaning to fix that for a long time, but if you lose some controls, you can just do that. So what am I going to do now? I can magnify Mercury, Venus, Earth, Mars, make Jupiter real big because he's really big usually. Whoa, that's a bit too big. Okay, so now we've got these planets quite a bit bigger, and I'm going to test your understanding of orientations now. I want them to be going around the sun. I want to watch them orbiting the sun. So what the heck would I do to get things moving? How do I get planets to start orbiting around the sun? What causes them to orbit around the sun?
Press the play button.
What's that?
The play button.
Right. You would have to have time rolling, right? Is that going to be really slow, like, 5 times real time, or do you think that's pretty quick?
Well, you could press the hamburger beside the speed of time flow and change it to maybe months, make it go faster.
Right. Oh, well, that would probably be a little bit fast, right? Because Mercury takes a little bit less time. So it's probably going to be hours or maybe days.
Yes.
Now, here's what I want to see when we're done with this. I want to see those planets all just moving around in their orbit, right? The sun is locked in the middle and the planets move around in their orbit. Let's see if that does that. Interesting. What's going on here? I guess they're kind of moving sort of slowly, a little bit. So we should probably go an even faster amount. How about days? There we go. Now we're starting to get some movement, right? And here's the thing. What if I had started us in rotate with the sun? We would have seen that. Background stars are moving and the sun is not, right? So in order to make this one look really good, we want to go into our tracking, hover as the sun rotates. Background stars are static. And we see everything moving around the sun, okay? So if you're looking for this really cool orrery effect, you've got to get time rolling really fast, and you want to make sure you're not in rotate with, you want to be in hover.
And if you were to save this as a favorite with the time rolling, would it save automatically to where if you click on it, it would
It
just
sure
start moving?
would. Yeah, you want to see that? Let's add a favorite. Let's go favorite, add favorite, and we'll call it orrery. And if I go to any other favorite, I'm going to load a black favorite, for example. Once I go back to orrery, everything's moving.
Awesome.
One little rule to remember, the more you play with ATM-4, the more you'll realize this is true. If you're planning to use it with ATM-4, it's a really good idea to preset that time, get the time looking the way you like it, but save it with time stopped.
Oh, okay, and then you'd press play afterwards to get it moving.
Or you would tell ATM-4 to execute the play. That's the more. The reason
okay.
you do that is because if you get a favorite set up perfectly, like I wanted Uranus to be right at the top, and as soon as I hit play, it starts going.
Yeah.
If your favorite is already playing and you want to go edit it, it's really hard. You've got to stop it. You've got to roll it back in time. You've got to edit it and then you start again. But if you save your favorites with time stop, in your show, it's really easy to hit play instantly, right? Very, very easy. But you know, if things are whizzing across the sky really fast and you try to go back and edit it in the future, that's really hard when you've got to stop time, roll it back, get the time going the way you like it, and start time again. So generally, Taylor, even if you are going to do that, I think it's a really wise idea to get into the habit of set the time the way you like it, get that time happy, but save it with time stopped, and then it's very easy to do that, right? Or in ATM-4, it's very easy to have a play cue, play time forward, okay?
Yeah. Thank
right.
you.
Okay, so we're about 10 minutes from the top of the hour. We're about at our break time. That's a lot of territory to cover, but any last minute questions, any things you want clarified? Okay. You guys are lucky. We used to do a big test on Friday at Institute. We would put everybody in a row of chairs and we would do a Jeopardy-like game show. We would put up make an orrery where you're hovering over the sun and you had like 2 minutes to do it. You had to run up to the console and do it. So you're lucky. You can go to the course notes and learn this slowly later. So
I mean, we can always edit the schedule, Scott.
yeah, right, right. It'd be interesting to try to do the game show over a Zoom meeting, wouldn't it? All right, guys, thanks so much for all of your attention. I hope some of this sticks, and please, by all means, go and read the course notes. The next one is going to be navigation, which is the fun stuff of flying around in space and making this all really, really pretty. So I'll see you in that session in about 10 minutes.